theorems help us solve mathematical problems. For instance, in an isosceles triangle, the base angle theorem states that the angles opposite to the congruent sides are also congruent, and its converse, the sides opposite to the congruent angles are also congruent. But how do we prove that this statement is true? Just stick around, for in this video, we will discuss how we're going to prove that two triangles are congruent. We will also prove the congruency of its corresponding parts. We will also apply the concept of congruency in solving the corresponding parts of congruent triangles. And we will also prove other related theorems. If you are new to this channel, kindly hit the subscribe button and the notification bell. And I promise that I will journey with you in learning math lessons and concepts in an easy way. Proving congruent triangles, solving corresponding parts of congruent triangles. After watching this video, you will be able to prove two triangles are congruent, proves congruency on corresponding parts of congruent triangles, and solve corresponding parts of congruent triangles. Now let's recall key terms and concepts that we discussed in the previous video. Considering these two triangles, the corresponding parts, angle A correspond to angle F and they are congruent. Angle B correspond to angle E and angle C correspond to angle D. And all these corresponding angles are congruent. Now let's take the corresponding sides. Side AB is congruent to side EF. Then side AC is congruent to side DF. Side BC is congruent to side DE. As you can see, these two triangles are congruent. When the two triangles are congruent, the corresponding parts are also congruent. And we call it CPCTC Theorems that states that corresponding parts of congruent triangles are congruent. In a conditional form, if the corresponding parts of congruent triangles are congruent, then the two triangles are congruent. To realize our objective for this video, we have to recall also the different types of triangle. Classification of triangle according to side. First, we have isosceles triangle. So it is a triangle with no equal sides. Isosceles is a triangle with two equal sides. And lastly, we have equilateral triangle in which all sides are equal. Classification of triangle according to angles. First, we have acute triangle. Acute angle means that the measure of the angle is greater than 0 degrees but less than 90 degrees. So in acute triangle, all angles are acute. So right triangle, it is a triangle with one right angle. So we know that it is right angle if you can see a box at the vertex of the triangle. Obtuse triangle, it is a triangle with one obtuse angle. So obtuse angle is an angle that measures greater than 90 degrees but less than 180 degrees. So this is angle B in this illustration. And lastly, we have equiangular triangle, which means that all angles are equal. So the sum of the angles of any triangle is 180. If the angle measures are equal, so each angle must have 60 degrees angle measure. We also have to recall what is an angle pairs. So the first angle pair is adjacent angles. How do we know that angles are adjacent? So these are two angles sharing common vertex and a common side. So if we have this illustration, so angle DBC and angle ABD are sharing common vertex, which is point B, and side BD is their common side. Complementary angles. So these are two angles whose sum of each measures is exactly 90 degrees. So these two angles are not adjacent, but the sum is exactly 90 degrees. These two angles are complementary angles. The next angle pairs is supplementary angles. So these are two angles whose sum of each measures is exactly 180 degrees. So these two angles could be an adjacent angle or non-adjacent angles. Next angle pairs is a linear pair. So linear pair are two adjacent angles whose non-common sides are collinear or forming a line. So in this case, this non-common side and this non-common side are collinear. So these two angles are a linear pair. So this one also, angle 1 and angle 2 are also linear pair. And same is true with this angle ETC and STC. Last is the vertical angles. These are two non-adjacent angles sharing common vertex and whose sides are collinear. The vertical angles can be formed when two lines intersect. Suppose we have angle 1 and we have this angle 2. So these two angles sharing common vertex, which is this point. Same is true with angle 3 and angle 4. So as you can see, we will try to look at angle 1 and angle 2. Their sides are forming a straight line. Angle 1 and 2 and angle 3 and 4 are called vertical angles. Parallel lines and transversals. So suppose line M is parallel to line N, cut by a transversal T. We have this line M, we also have another line N here, and these two lines are parallel. We have another line and we call it as transversal. The name of the line is line T. Then what is a transversal? So by the way, transversal is a line that passes through two lines in the same plane at two distinct points. Line M and line N are parallel lines, and this is line T. So this line T passes this line M here at this point and crosses to line N at different points. So that line is called transversal. So as you can see, we have 8 angles being formed here. The angles inside, angle 3, 4, 5, and 6, we call it as interior angles. Outside, of course, these are the exterior angles. When two parallel lines are cut by a transversal, we can name different types of angle pairs. First is the corresponding angles. So angle 1 and angle 5 are corresponding. This is the transversal. One is upper left, and this is also upper left at the bottom group of angles. So angle 2 and angle 6 are corresponding. Angle 3 and angle 7, 4 and 8 are also corresponding angles. So take note, because in the different theorems later, we should know how to determine the corresponding angles and the other group of angle pair. What is alternate interior angles from this illustration? Since the interior angles are the following 3, 4, 5, and 6, alternate interior are angle 3 and 6 and angle 4 and 5. Alternate exterior angles is angle 1 and angle 8, angle 2 and angle 7. Same side interior angles, angle 3 and angle 5, angle 4 and angle 6. Same side exterior, these are angle 1 and angle 7, angle 4 and angle 8. And lastly, we have the vertical angles, angle 1 and angle 4, angle 2 and angle 3, angle 5 and angle 8, angle 6 and angle 7. Now, there is a postulate states that if two parallel lines are cut by a transversal, its alternate interior angles are congruent. So, the alternate interior angles are 3 and 6 and 4 and 5. So, therefore, we can say that these angles are congruent based on the given postulate. Now, out from this given postulate, we can actually generate several theorems. Now, let's suppose that angle 3 measures 70 degrees. Find the measures of the other 7 angles. So, angle 3 is 70 degrees. So, what would be the measure of angle 6? So, based from the postulate, the measure of angle 6 is also 70 degrees. Now, what would be the measure of angle 5? So, as you can see, that angle 6 and angle 5 are linear pair. The sum of these angle measures is 180 degrees. So, 180 minus 70, so this must be 110 degrees. Same is true with angle 4, since they are alternate interior angles, so it is also 110 degrees. Now, angle 7 is 70 degrees. Now, as you can see, these two angles, 5 and 7, are also linear pair. Angle 1 is also 110 degrees. Now, angle 8 is 110 degrees. Then, angle 2 is 70 degrees. Now, out from this proof, we can have several theorems concerning this group of angles. So, first, if two parallel lines cut by a transversal, then, as you can see, the corresponding angles, what are they? So, angle 1 and angle 5, angle 3 and angle 7, angle 2 and angle 6, angle 4 and angle 8. As you can see, their measures are congruent. Next is the alternate exterior angles. So, the alternate exterior angles are angle 1 and angle 8, angle 2 and angle 7. As you can see, their measures are equal or congruent. Thirdly, the vertical angles. So vertical angles 1 and 4, 2 and 3, 5 and 8, 7 and 6. And they are also equal. How about the same side interior angles? So same side interior angles are angle 3 and 5, 4 and 7. So they are not equal, but there is distinct relationship. Their sum is equal to 180 degrees. Two angles whose sum is 180 degrees, we call it a supplementary angle. So same side interior angles are supplementary. And same side exterior, 2 and 8, 1 and 7 are also supplementary. Now, let's have proving on corresponding parts of congruent triangles. From this figure, we can say that the given are the following. Segment JK is congruent to segment ML. And also, JM is congruent to segment KL. So, based on its identical markings. So, we are asked to prove that angle J is congruent to angle L. In proving that these two triangles are congruent, we need to establish first that these two triangles are congruent. We will do two-column proof. So first statement, segment JK is congruent to segment ML. So this is the given statement. So second statement, JM is congruent to KL. Again, this is a given statement. So we just put the given in our first two statements. So as you can see, KM, which is common to these two triangles, so segment KM is congruent to segment KM. So what support us that these two statements are equal? So the first property of congruent, reflexive property, will justify that this is true. Then, since all the three sides are congruent, now we can now conclude that triangle KJM is congruent to triangle MLK. Again, by side postulates, because the three sides of these two given triangles are congruent. Based from the CPCTC Theorems, if the two triangles are congruent, its corresponding parts are also congruent. Therefore, we can now conclude that angle J is congruent to angle L by virtue of the corresponding parts of congruent triangles are congruent theorem. Next, so the given is angle A is congruent to angle D. And segment AB is congruent also to segment DE. So we are asked to prove BC is congruent to CE. So first, of course, the given statement, angle A is congruent to angle D. Second, AB is congruent to DE. So based from the illustration, they are equal because that is a given statement. So what do you think are the parts of these two triangles that we can say that are congruent? So in this case, we can say that angle BCA, this angle, is congruent to angle ECD. What is the reason? Because this angle and this angle are vertical angles. And based from the previous slide, vertical angles are congruent. Therefore, we can now conclude that triangle ACB is congruent to triangle DCE by virtue of angle-angle side postulate. So the two angles and the non-included sides of the first triangle is congruent to the two angles and the non-included side of another triangle. Then we can conclude that the two triangles are congruent. This is from the AAS postulate. What is asked? Segment BC is congruent to CE. Therefore, we can now conclude that this statement is true because of the CPCTC theorem. Next example, we have the given statement. So angle A is congruent to angle H, and segment MT bisects angle AMH. So this segment divides this angle AMH into two equal parts. We are asked to prove that segment EM is congruent to segment HM. So the first statement is the given statement. Second, the other given statement. So from this given statement, what can you infer from the statement number 2? What is bisect? Bisect means divide the angle into two equal parts. So therefore, we can say that angle AMT is congruent to angle HMT. Again, by the definition of angle bisector. This side is common to the two triangles. We can now have statement number 4 that segment MT is congruent to itself because of the reflexive property. So therefore, we can conclude that these two triangles are congruent by virtue of the EAS postulate. Now, what is us since these two triangles are congruent? So we can now conclude that this statement is true by virtue of the CPCTC theorem. Example number 4, triangle AMH is an isosceles. That would mean two sides are equal. So segment AM is congruent to segment HM. Third given statement, segment MT bisects angle AMH. So we're asked to prove that angle A and angle H are congruent. The first given statement and the reason is given. Second, EM is congruent to HM. So the reason is also given. So these two sides are the congruent sides. Third statement, this segment bisects this angle EMH. So since this segment bisects or divides this angle into two equal parts, so we can say that angle AMT, this angle is congruent to angle HMT by definition of angle bisector. Fifth statement, so this segment MT is common side of these two triangles. So by reflexive property, these two segments are congruent. We can now conclude that these two triangles are congruent by virtue of the side angle side postulate. So therefore, we can now conclude that angle A is congruent to angle P by the CPCTC theorem. Now, let us know the different parts of an isosceles triangle. So isosceles triangle, based from definition, this is a triangle with two equal sides. And the two equal sides, we call it as leg. The vertex where this common side meet is called the vertex angle. The side opposite to the vertex angle, we call it as the base. The included angle of the congruent sides and the base, we call it as the base angle. Now, based from this illustration, now as you can see, the two angles which are opposite to the two congruent sides are also congruent, and we can have this base angle theorem of an isosceles triangle. So if the two sides of a triangle are congruent, now you can conclude that the two angles opposite these sides are also congruent. Now let's can have the converse. If the two angles of a triangle are congruent, then the two sides opposite to these angles are also congruent. Let's have example number 5. This is a quadrilateral WXYZ and this is diagonal YX. So the given statement, YX is parallel to YZ, so we have put an arrow mark on each side. Another given statement, so we're asked to prove that angle W is congruent to angle Z. So first statement, the given statement. Also, the second statement will be the other given statement. Now, as you can see, that this diagonal is also known as a transversal because this line intersects these two different lines at different points. Now, based on the theorem that the alternate interior angles are congruent, therefore we can conclude that angle WYX and angle ZXY are also congruent. Now, since this diagonal is also common to these two triangles, segment XY is congruent to itself by reflexive property. We established that the two sides and the included angle of these two triangles are congruent. Therefore, we can conclude that they are congruent by virtue of the side angle side postulates. What is asked to prove is angle W is congruent to angle Z. Now, we can conclude that this statement is true by virtue of the CPCTC theorem. Based from the CPCTC, we can also conclude that these two sides are also parallel, and we all knew that the definition of a parallelogram, the opposite sides are parallel and the opposite sides are also equal. So we can say that this is also equal by CPCTC theorem. Now, this angle, angle W and angle Z are also known as the opposite angle. Therefore, we can now have another theorem pertaining to parallelogram that if a quadrilateral is a parallelogram, then its opposite sides are also congruent. Now, let's solve the corresponding parts of congruent triangles. Triangle ONE is congruent to triangle SIX. The measure of angle E is 65 degrees and side IX is 460 centimeters. So we're asked to find the measure of angle X and the segment EN. So first, as you all knew that these two triangles are congruent, so this angle E corresponds to angle X. Therefore, the measure of angle X must be 65 degrees. And also, the measure of side EN is 4 centimeters, the corresponding side of IX. So another given, this triangle ABC is congruent to triangle FED. And segment AC is measuring 43 units, BC is 36 units, EF is 28 units, DF is 2x plus 3, and measure of angle F, we were asked to find the value of X and the measure of angle C. So first, AC is congruent to DF, so AC is congruent to DF, and they are corresponding sides, so therefore we can equate them. So the measure of DF is 2x plus 3. The measure of AC is 43. So equate them. So 2x equal to 43 minus 3 by virtue of addition property of equality. Then 43 minus 3 is 40. Solve for x. The value of x is 20. Now, what is the measure of angle C? So angle C is the corresponding angle of angle D. Now, in the second triangle, this angle measures 90, and this angle is 62, which is the given. Now, the sum of the three angles of this triangle or of any triangle is equal to 180 degrees. Now, for us to get the measure of angle C, we have to know what is the measure of angle D. Now, to solve for D, 180 minus the given angles, 90 degrees minus 62 degrees. Now, 180 minus 90 minus 62 is 28 degrees. Now, 28 degrees is the measure of angle D, and they are corresponding angle to angle C. So, therefore, the measure of angle C is 28 degrees. Now, let's summarize the concepts that we learned for this video. So, first, the CPCTC Theorem. Second, that if the two parallel lines are cut by a transversal, its alternate interior angles are congruent. Now, out from this postulate, we can have several theorems that if two parallel lines cut by a transversal, then the corresponding angles are congruent. The alternate interior angles are also congruent. The vertical angles are congruent. The same side interior angles are supplementary. Then same side exterior angles are also supplementary. We also knew that the sum of the angles of any triangle is 180 degrees. The linear pair is supplementary. The base angle theorem of an isosceles triangle, that if two sides of a triangle are congruent, then the two angles opposite these sides are also congruent. It's converse. If the two angles of a triangle are also congruent, then you can say that the sides opposite these angles are also congruent. And finally, we have the theorem about quadrilateral, which is parallelogram, that its opposite angles are also congruent. After learning the lesson for today, now it's your time to measure your understanding of this lesson. Write your answer in the comment section below. Suppose in this given illustration, so question number 1, question number 2, question number 3, you are going to make a two-column proof proving that triangle ADC is congruent to triangle ABC. So we're just supplying the missing statement and or reason. Number 4, you're asked to prove that angle M is congruent to angle O. In example number 4, you are to supply all the necessary statements and reason in order to prove that this statement is true.
Thank you for finishing this video. If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share this video so that I will be able to continue to journey with you in learning math lessons in an easy way. See you in our next video. Thank you for watching.